Welcome to Perfection's Clutch Installation Lab. This is a 1997 Dodge Ram 3500 5.9 liter Cummins with the NV4500 5-speed transmission. 184,000 miles on the truck. Now I've already taken the transmission out, the clutch is out, but I put the bell housing back on. We're going to use this to help understand and explain a problem we see in clutch discs occasionally. We're going to look at clutch discs and the torsion damper, but specifically the spline, the teeth right here that drive the input shaft. This is a GM 1x14 spline. The spline size is much smaller now. The teeth have lost profile. Those teeth were kind of shaped like this, and with this wear, they've gotten sharper. Something's wrong. That's telling me something's not right. This one, the spline is also sharper, and the hub moves up and down inside the disc. It actually moves up and down. Shouldn't do that. We even see discs that look like this. We've got the friction material in one entire ring and the torsion damper in another. First glance, that looks like too much horsepower, but I think there's something wrong in the environment that caused this problem. So we're going to use this truck to explore concentric misalignment and angular misalignment of the input shaft to the engine. So there's our clutch. It's all bolted up on the flywheel. We use the alignment tool to center the disc. Here comes the transmission. It's installation time. Transmission is coming in. We pick up the teeth, go through the teeth, and if it's equipped, we pick up the pilot bearing. That's what's supposed to happen. But what if, when you're installing this transmission, when you're all done, what if the input shaft is no longer lined up concentric with the crankshaft? Start the engine. The clutch disc turns and the input shaft is orbiting around trying to keep up the new center. It's not very good. Doesn't do the transmission any good, and it really causes a problem on our clutch discs. Next problem. Clutch disc is installed, everything is there, the input shaft is coming in, we're installing the transmission, but at the very last, when it's all bolted up, the input shaft is now at an angle relative to the disc. Start the engine up, the input shaft is now wiping as it turns across the teeth of the disc. Doesn't sound like it's very possible. You use the alignment tool to install it, but the real problem lies in how the transmission or bell housing is aligned perpendicular and concentric to the crankshaft. Now this is rear wheel drive with a separate bell housing. This lets us actually measure whether or not it's concentric and if it's parallel to the back of the engine. If you've got a front wheel drive with one piece transmission, transaxle, this doesn't work, at least the measuring part. If you've got rear wheel drive with a one piece transmission case and bell housing, the measuring doesn't work. But the same concept of concentric alignment or angular misalignment applies to all these. We just get to actually see it here. So we're going to go through the factory service manual procedure to measure the concentric alignment and also inspect for parallelism from the flywheel to the back of the bell housing. Now the dial indicator is a magnetic base coming off of the flywheel in this case, and we're touching the inside bore of the bell housing. So we're going to consider that our 12 o'clock position and 0. Manual calls for you to rotate and mark every 45 degrees. Now in the Cummins, they've got a thing called a barring tool. It's a little tool that intersects the ring gear, and I can actually use a ratchet to turn the engine over. That's the negative direction, and that's -3 thousandths. I'm just going to mark it as a -3. We'll call that -19 also. -2. And back to 0. Now we've got the indicator values written on the bell housing, and according to the Dodge factory service manual, quote, Subtract each reading from the one 180 degrees opposite to determine magnitude and direction of runout. End quote. What we're looking at here is this whole bell housing needs to come down about 0.010 of an inch. The distance from here to here is greater than the distance from here to here. So you need to split the difference and bring it down. I heartily recommend you get a factory service manual, read it, get some help, follow along, get your math right. You don't want to make a mistake here. But this bell housing would need to come down. Now the factory manual also states that the maximum total indicated runout for this bell housing bore is only 0.15 of an inch. So we're a little bit off. Now we've measured the face runout, and starting at the 12 o'clock position was our 0. Over here at 9 o'clock, we were 0.8 thousandths further away from the flywheel. 6 o'clock, we were 15 thousandths further away from the flywheel. And 3 o'clock, we were about 0.8 thousandths out again. Now, quoting from the factory manual, quote, subtract the lowest reading from the highest to determine total runout, end quote. So if we subtract 0 from 15, we get 15 thousandths of an inch runout in this particular case. The correction would be to add shims, 15 thousandths value, in the 12 o'clock area. We had a 7,000 shim in the 9 o'clock area and a 7,000 shim in the 3 o'clock area. That would bring those sides up to equal that 15. This is an illustration. This particular bell housing, this particular shop manual, please consult your shop manual for your specific vehicle. Be careful how you measure this. Use the factory specifications in your manual. We're trying to illustrate how a bell housing can be off and create alignment problems in both the pilot bearing, input shaft, splines of the hub, and the torsion damper. Now I will admit that that procedure of indicating the bore and checking the runout on the face of the bell housing is a bit involved, and you can only do it on these older transmissions that have a separate bell housing. Integrated bell housing transmission combinations, transaxles, can't do it. But anytime you take a clutch out and you see that the splines are misshapen, they're sharpened, they've got a big burr, or the hub moves up and down inside, better start challenging the alignment of that input shaft to the crankshaft. My real concern is that any time that you do a transmission replacement, an engine replacement, or even take the transmission out to install a clutch, is that one of these sleeves falls off and is lost in the shop and not observed when you put it back together. This is critical. We did an installation a couple years ago on a Dodge Diesel 6-speed, and when we took the transmission out, one of these sleeves was missing and the disc showed signs of alignment damage. We looked at the transmission, and with the owner, we were able to determine that the transmission had been previously replaced. It was a rebuilt transmission. The rebuild wasn't the problem, but when they took the transmission out, sent the core back to the rebuilder, that sleeve went with it and they never caught it. So please, please check these. Major concern. Another concern, as you're installing the transmission, you get the transmission up in there against the sleeve, you start to get on that dowel sleeve or pin, and if things aren't going too well, this is not the time to use force, it's the time to use some finesse and guide it in. But we think once in a while there are these long bolts that get used to pull it in. If you pull it in, then these sharp sleeves are going to catch on the aluminum, gouge it, cause a burr. That again damages this critical alignment. So we're fortunate enough to have a new bell housing and a new adapter housing here. Let's go ahead and start hanging some parts in this Dodge and get it back on the road. To install the flywheel, I'm going to insert my pin, same size, pitch as the flywheel bolts, no head, little screwdriver slot cut in it. Insert that pin up there at 12 o'clock position. This makes it very safe to pick up the flywheel hang it on the pin. And I've already got the bolts ready. Bolts are all clean. All the hardened washers are in place. Drop of thread locking compound. And let's just start the bolts by hand. Without that pin, you've got about a 50-pound flywheel you're trying to hold up in the air. So get yourself a bolt, make a pin, and keep it if you work on these engines. Now to hold the flywheel, it's just a piece of channel with some holes in it. I'm going to put one bolt in the flywheel. And one of the bolts that holds the transmission onto the adapter. that holds the bell housing on. And that will hold the flywheel as I tighten it. First, just going to go around with a ratchet and just seat all 8 bolts. The torque spec on the Cummins bolt right here is 101 pound-feet. We're not going to use an impact gun, we're going to use a torque wrench and we'll take it down in 2 steps. We're going to start off at about 50. Now the torque wrench is set for 101, and this is always going to be in a crisscross pattern. Everything I've done is crisscross, staggered. Here we go. And the final check. All 8 bolts torqued to 100 pound-feet of torque. Now I've got the dial indicator set up on the face of the flywheel. We're going to use the barring tool, rotate the engine 1 turn, and observe the flywheel face run out. Here we go. And there we are back to our starting point. Now that was less than 2/1000ths of an inch run out on the friction surface of the face of this flywheel. First, everything is cleaned up. The guide tube on the front of the transmission is cleaned up and polished up with a piece of Scotch-Brite. Each tooth of the spline has been carefully cleaned, and I use a screwdriver blade and a small piece of Scotch-Brite and go down and clean those. The surface out here where the clutch pilot bearing rides has been carefully cleaned up. So we're in good condition there. Clutch release bearing. This bearing has a feature called self-aligning. The bearing itself moves on the carrier back and forth. When you look at it, it looks like it's off center, and it may be, but as soon as you install it, start the engine, press on the clutch pedal, the fingers of the diaphragm spring will get a hold of the release bearing and move it where it wants it to be. Reduces heat on the bearing, makes it last longer. It is a feature, not a problem. Self-aligning. You can't figure out where it needs to be, just install it. Now we're also installing a new clutch release fork. I've already installed the retaining clip back here on the pivot ball side, which is on the passenger side. But this fork has one unique characteristic. It can be mounted on both sides. Only one way is right. I marked the crown on the fork right here with white paint, and I also underlined the part number. Now if it's installed correctly, the crowns line up directly in line with the input shaft. That's where the clutch release bearing rides. But if I flip it over, which it can easily do, now the crowns are over here. We've got a flat spot of the fork that pushes against the bearing, and the part number is up here. This is wrong. This would have a funny feeling clutch, maybe some noise. We want it to go like this. Lubrication points. We're going to put a little bit of grease inside the pivot ball down there. A bit of grease on the pivot over here. And also put a little bit of grease in the pocket where the master cylinder push rod goes. And we'll put a little bit of grease also on these contact points for the bearing. But here's the area that I really want to make sure everybody understands. And I'm going to make a bit of a mess doing this, but I got to do it. This bearing has a guide tube grease groove. We need to make sure that that grease groove is fully packed with grease. I'm just tuning it up a little bit here. And I'm also coating all of the surface that this rides on. I want to make sure that this has a nice uniform film of grease inside there. I'm also going to put a little bit of grease on the guide tube itself. I want a nice, smooth feeling clutch. We just did an NV4500 couple months ago, and the technician didn't install, when he installed the bearing, didn't grease the groove, and it really made a mess out of the clutch release bearing. That video is also on YouTube. So I'm going to go ahead and put the bearing on the fork, and then we'll put the bearing and fork on the transmission. It was a little easier to put the bearing on the fork when it's on the bench, so we're going to install the fork and bearing as an assembly. Wipe up that excess grease. I'm just going to go ahead and snap the fork into position. There we go. That would roughly be the installed position. The slave cylinder the slave cylinder push rod is going to push on the fork. The fork is going to come forward. That's release. Engaged. We've got all our pressure off of the hydraulic system. And then to accommodate for wear, as the clutch disc gets thinner, the finger height increases, the clutch release bearing has to move back towards the transmission. So I want this to be nice and smooth, and you can see a nice action there. And remember, the reference for the fork is the part number in the lower left-hand corner. Looks good. Now it's time to lubricate the input shaft on the transmission here. We put a small pack of grease in the kit. High temperature wheel bearing grease will work just fine. Want to just spread that grease around. The trick here is always trying to keep your hands clean, because in a few minutes you're going to be handling that disc. Now, this is steel. The hub on the clutch disc is steel. Steel rust. This grease is there to try and help prevent the formation of rust, to inhibit it. We can't put anything real sticky on there. You got to have something that'll allow the disc to slide during release. So a little bit of high temperature grease. Now I often see returns or talk to technicians that go, well, what if I use this, or what if I use that? Well, if it's a high temperature wheel bearing grease type product, you're in good shape. The one thing I don't want you to ever use right here is anti-seize. Anti-seize will fling from the input shaft out to the friction surface, and then we've got an anti-seize compound on our friction. That's not good. Now we're going to take the disc up to the input shaft and slide it on and distribute that grease. Slide it off, index it, distribute that grease. You want to make sure that that disc fits right now, and keep the friction material clean. There's a flywheel side orientation on almost all discs. If you have any doubt about which way a disc goes, please call us. Now to prepare for installation for the clutch, I want to take a clean shop towel, some brake clean, and wipe down the flywheel a couple of times. Change the towel. Now I don't want to use any solvent from the solvent tank, any type of fuel product. You could use rubbing alcohol or some type of brake clean product. And change the rag out a couple times and get all that cast iron machining oil off of there, preservative. This is a friction surface. We want it real clean. Now in this application, the flywheel has a hole in it for the pilot bearing. I already installed that while it was on the bench. I like to do it on the bench. I've got everything in front of me. I put the pilot bearing in. There's a couple different techniques. If you have a shop press, you can press it in. If you have a piece of threaded rod or a bolt, you can make a small little mini press quite easily while this is on the bench, and very carefully, very controlled, pull it in. Or put something over the pilot bearing and very carefully tap it in with a hammer, but don't use a direct blow on the pilot bearing. This is the alignment tool. The alignment tool centers in the pilot bearing with the clutch disc during the installation process. We want to make sure that when we do it, we have the disc in a good position, and we'll check the alignment a couple of times. So the pressure plate is clean, the flywheel is clean. These are those two pins that I like to use. Put them over here on this side and on this side. And that just helps me hold the pressure plate while I start some bolts. Now all 8 bolts are in. I took the last 2 pins out, replaced them with bolts. So now I'm going to pick up the disc with the alignment tool. Center it on the pilot bearing nicely, hold it. I'm just going to tighten a couple of bolts. Just snug them up. Now we really want to take a minute and check this alignment of the disc and the pilot bearing. You want to make sure it feels real good, so work the tool in and out several times. You shouldn't hardly be able to feel it pick up the pilot bearing. It should be that centered. If you're fighting it later on, you're going to be asking yourself, did I get that disc centered on there? I don't know. So take a minute, line it up. Now I'm just going to snug all these bolts. Last check. Slides in and out very good. So we're done with the alignment tool. Now for the tightening process, we'll just start with a hand ratchet and draw them down in a staggered pattern. No impact tools. This is the time to take your time. Bolts are all seated. Final tightening, 22 pound-feet. Final check. Clutch is installed, ready to put the transmission up there. Transmission's back in, drive shaft, everything is hooked up except the hydraulic system. I noticed that the reservoir, the fluid level, was lower than it should have been, than what was normal. This is a pretty good indication the fluid was going somewhere, and it's all wet right here on the slave cylinder. So we're going to pull this boot off, but it's time to put hydraulics on this truck and complete this job. Now there's the moisture that you can see from the .3. I'm trying to pull this boot off. And there it is. We've got .3 leaking out. So we definitely need a slave cylinder. And we're going to put a master cylinder on it too. Well, the first thing I did was I took the system to the bench, used a 1/8 pin punch, tapped the roll pin out on the line for the master and the slave cylinder, cleaned up the line, blew it out, put the new seal on the end of the line, inserted it into our new master cylinder, put the new roll pin in there and tapped it in, did that on both ends. Now to start the bleeding process, I've got it fixtured using this jack safety stand. I've got the reservoir at the high end. Notice the angle of the master cylinder. An air bubble can come out here and not be trapped in this system. We're going into the line. We pretty much have a downhill fall all the way to the slave cylinder at the bottom. Now at the slave cylinder, I do one other thing a little bit different. I like to do this. I'm going to use a steering wheel puller and block the piston of the slave cylinder from extending. This will both allow me to test, make sure it's fully bled, because when it's fully bled, I won't be able to move that push rod more than about 1/8 of 1 inch. But I can also remove the screw and insert a long Phillips screwdriver, for example, in there. And I'll show you how we're going to use that to compress the slave cylinder and force air bubbles out the top. So we're going to begin by filling it up with .3. Always using clean, fresh .3, never anything that's recycled. You just go ahead and fill that reservoir up. Now, it's already bubbling, so a bubble coming out, that means fluid going down in. Now we're going to go down and open up the bleed screw, the vent, on the slave cylinder. We're We're just going to open the bleed screw or the bleed vent, keeping it pointed up. And let that run for just a little bit, and keep an eye on the reservoir. Make sure you don't run out of fluid up there. And I can see it kind of gurgling back here on the back side. I'm going to keep that position so that if an air bubble is up there, it would go out. If I have it turned down like that, I'm going to get fluid out, but the air bubbles are going to be up here. So let's keep it up here. Just going to let that run a little bit. That looks good. And we're just going to close it off. Now, I really don't think the system is completely bled right now. So this is going to be a one-man process. Let's go to the next step. Now I removed the screw from the steering wheel puller. We're not going to use that right now. You could use a Phillips screwdriver in this case. You could use a 3/8 extension. I want to put it carefully in the hole through the steering wheel puller, and I'm going to use that to push on the piston of the slave cylinder. And I'm going to point it down, and all the tubing, everything is just pointed uphill. And I'm going to push down on the slave cylinder and just watch for bubbles in the system. We're burping bubbles out the top, not throwing away fluid that we already put in there. We'll let it extend. It's going to pull fluid down slowly. I want to make sure that that reservoir never runs out of fluid. Do it again. We'll just do this a couple times. And after a little while, it'll be nothing but steady fluid. Each time you push it in, compress it, and then let it extend. It'll pull fluid down all by itself. There's a spring inside the slave cylinder pushing the piston out, and as it does that, it pulls in fluid. Compressing. Now this may look like a rather involved setup, but if you've ever struggled with bleeding a system in a truck where you've got unknown pockets of trapped air, this looks like pretty well spent time here doing it on the bench, and then we're going to prove that it's bled before this is all done. Now additional techniques that work out real well. Seems like a little bit of voodoo science here, voodoo repair. If you tap on the line, it can dislodge air bubbles. And you'll see a little air bubble come out every so often. We want to get every bubble out and make this solid fluid. Now I'm going to go ahead and put the screw back in and turn it until it contacts the slave cylinder piston. Now this master cylinder uses a slightly different arrangement. It uses piston port. There's a piston and a port, and the piston has to move forward and close off the port. Once the port's closed off, then we start to create pressure. So how do we know when it's bled? When you push on this, I'm going to use the screwdriver, not the push rod right now. I'm going to push on it and feel how far it moves before it goes hard. We're about 1/8 of an inch. And that little flutter you see in the fluid is the distance that the piston moves before the port is closed. I think we're ready to install. Now to install the safety start switch, there's two little clips right here. Squeeze them together, slide it back, the keeper slides off. I think it's easiest to just push the push rod in right now, get the lock in. When the pedal goes forward for release, the switch engages and you can start. Push the keeper down in place, just slide it forward, the two little ears will lock in. Take the buffer, put it on the master cylinder. You get one insertion on that keeper, it stays put. One good click, and there it is. So we're ready to install this one in the truck. It's all built up. Well, the installation is complete and the test drive went very, very well. Clutch releases. We've got good reserve travel before the clutch starts to engage, so we're getting a good clean release. Nice smooth engagement process. Handles all the power that the Cummins has. Now we did install a lot of new parts and we explored a lot of things on this particular installation. We replaced the housing that goes between the engine and the bell housing. We replaced the bell housing. We replaced the flywheel, the pilot bearing, the clutch disc, the pressure plate assembly, the release bearing, the clutch release fork, a new master cylinder, and a new slave cylinder. But the big area we were exploring was the alignment issues. Here's that little dowel sleeve that centers the input shaft to the crankshaft. Very, very important. These are missing. We've got alignment problems. But I want to use these old parts and illustrate one other potential problem. As you're installing the transmission, if anything gets between the engine and the transmission or the housing as it's coming together, we've now created an angle. That foreign object becomes a shim, causes an angle. We've got angular misalignment of the input shaft to the clutch disc, and we get premature wear of the clutch disc, input shaft, and the pilot bearing. A lot of damage will be seen there. This could be a ground strap, it could be a wire, it could be a vacuum line, it could be a bracket, it could even be a lot of grime underneath the truck that gets compressed between those two surfaces. So keep it clean and be careful as you put this stuff together. If you have any questions about a clutch, the correct clutch for your diesel pickup truck, a flywheel, or a hydraulic system, please call Perfection toll free at 800-258-8312. Press 4 and your call will be routed to Tony, Steve, Bobby, or myself. We'll be glad to take your call and help you out.